5 normal models answer key. All right, let's first of all look here and see the mean. The mean is affected by by anything: multiply, add, subtract, or divide, anything. So what I've done to this is I've added 35 and I've multiplied by 73. So the mean is going to receive both. That's why I'm adding 35. And then I'm also multiplying by 3, or 73, excuse me. Adding 35 and multiplying by 73 to get $1,250.45. If you were scoring this, you would score this. You would have your work, the answer, and then that you put a dollar sign. Standard deviation is only affected by multiplying and dividing. So the fact that it's adding 73, I don't do. So adding 35, I don't do. So I just multiply it by the 73, and that's where I get $216.08. And again, there's 3 point systems on this. Median is affected by both because it's a spot, it's a measure of position. So I'm adding and multiplying, so then I get $1,203. IQR is a spread, and the spread is just like the standard deviation, is a spread where it's only affected by multiplying and dividing. So I only multiply by the 73, and again, the 3 points to get $292. All right, there's a couple different ways you can do this one. One way that I did is I chose to do the Q3 plus 1.5 times IQR, which is Q3 minus Q1, and found that my 28 is actually above the 25, which this is equal to, because it's equal to 25. And since it's outside the fence, we called it an outlier. Another way you could do it is you could do 2 standard deviations, where you could say, okay, well, the mean is equal to 16.65, and 2 standard deviations is going to be 2 times 2.96. And then that's going to get you, because anything above 2 standard deviations we call unusual, we call an outlier. So you could go 2 times 2.96 and then plus 16.65, and that is equal to 22.57, so it still would be an outlier. Another way you could do it is also considered unusual, is the 3 standard deviation rule, and that would be 3 times 2.96, and then you would add that to 16.65, and that would be 25. So any method is going to consider 28 an outlier, but you could do the 3 standard deviation rule, 2 standard deviation rule, or the IQR rule. Okay, for this one, this needs to be IQ scores, needs to be down here, and this needs to be all right, and the points would be 15 points, where you have a title, label, 68%, 95%, 99.7%, and N 115. Okay, for this one, adult females, what you need to do is, it's asking what's more unusual, and so to be able to compare them completely, we're going to find z-scores, and we see that this z-score, so if I were to put this on here on the model, the Dalmatian, -1, -2, -3, -4, the Dalmatian is going to be here, -1.52, and the boxer is going to be here at -3.24. So you can see that this is the mean. This is the mean. So this one's further from the mean, therefore it's more unusual. So the one that's further away from the mean is more unusual. You have to make sure that you build the connection. You just don't say, hey, this is a lower z-score. Then tell me what that means. That means that it is more underweight. Okay, for number 4, the first thing you're going to do is you're going to write your probability, or your graph, you're going to draw your graph. So I'm looking for the probability that my value is below 97. So I'm drawing my picture, writing my probability statement. So when I write my probability statement, I have P less than 97 and my z-score, then I turn it into a z-score. Then I choose to either do normal CDF or a chart, and I do normal CDF, lower bound, upper bound, mean standard deviation, or I do a chart and I find a z-score of -2.42 and find about 0.75% of the people have an ear temperature that can indicate hypothermia. Okay, for this one here, for part B, I know that my IQR is Q3 minus Q1, and I do know that I have a mean of I have a mean and a standard deviation, so I honestly, this is one way to solve it. There's a little quicker way to solve it, which I'll show you in a second. But if you'd solve it with z-scores, you would solve it here, finding, okay, this z-score is going to be negative 0.67, and this z-score is 0.67. So you know that my probability statement is the probability that x is less than q1, because there's my picture, is going to be 0.25. I don't know q1. And then you could solve it by finding, because I know my z-score of 25% is, that should be a negative 0.67. And then you're going to see that that's 98.2. Similar speaking, you're going to do the same thing with Q3, except you're going to use positive 0.67 because you get a z-score of positive 0.67. Okay, the other way you could have done it is area 0.25, your mean, you could have just go ahead and put in, because you know your mean, 98.7, and your standard deviation of 1.7, and same thing with here, 98.7 and 1.7, and this would give you directly the value of 99.2 and 98.2. So that's a little quicker way to do it. You definitely are able to do that. And the last step is, of course, to find the IQR, the Q3 minus Q1. Okay, the final one, let's look at this here, is let's see what we're trying to find. So I'm trying to find this here. I want this, my IQR, to be 0.5. Well, first of all, I want you to notice that this here and this here between is exactly the same. They're both 25% of the curve away from the mean. Same, so they're the same distance. So now what I showed you from above is the z-score of 25% is 0.67. Of course, if you define that, you would do inverse norm area 0.25, mean 0, standard deviation 1, and that's going to get you 0.67. Negative 0.67. If you find the 75% one, where the area is 75%, you're going to get positive 0.67. So what that tells me is that, look down here on this one here, if you see that the standard deviation is negative 0.67 for Q1 and positive 6.67 for Q3. So I want you to see that Q1 is just equal to 98.7, my mean, minus 0.67 standard deviations, and Q3 is 98.7 plus 0.67 standard deviations, because it's 0.6, it's not a full standard deviation away, it's a little less than standard deviation away. So I'm just going to use Q3 minus Q1, and I'm just going to substitute it in. So here's my Q1. So I substitute that in for Q1, and here's my Q3. Substitute that in for Q3. And then I'm going to get, of course, it's equal to 0.5 because that's what I want. And then I just simplify. You can see when I start to do the math, the 98.7s cancel out. And I end up with this one add with this one, because negative is positive. And then I finally get standard deviation is 0.37. All right, I hope you understand that. If you have any questions, let me know.